Today we'll speak about identities, some difference and cofunctions identities. That is, to start with this section, we need to just keep in mind sign preserve the sign, which means if this is a plus, that will be plus, and if it is minus, it will be minus, and alternate means it will be sine, then times cosine, then cosine times sine. While cosine will take opposite sign. If this is a plus, plus, and will be both cosine first, then both sine first. For tan function, the numerator will keep the same sign. Then if this is a plus, that will be minus, and here it is minus, so numerator will be minus. Then we go opposite sign, it will be 1. Regarding the cofunctions identities, it's actually complement angle identities, which means if we have sine 90 degrees minus theta will be cosine theta, like sine 60 is actually equal to cosine 30, and cosine 30 is equal to sine 60, and so on. So it's complement angle identities. Sine 90 degrees minus theta will be cosine, cosine 90 degrees minus theta will be sine, and so on. Cotangent 90 degrees minus. Going to the first question. Here we have find the exact value of sine 45 plus 30, applying the rule we had is equal to, as we said, sine preserve that's cosine alpha sine beta. Now 45 will mean sine 45 cosine 30, 45 sine 30 angles. That is, sorry, 30, so that's 45 and 1 and square root of 2. So as root 2 over 2 by multiplying by the conjugate. So we will have times cosine 30. Now cosine 45, it's 1/2. There is 4. Root plus root 2, and that's the best. The second question, we have cosine. So we have cosine 45. So we remind ourselves about the rule. The rule says means. So we will have both sine beta, sine alpha. So applying this one, we will get this is cosine 30 times sine 30. Just mentioned, or the table. This is 30, that will be 60, that's 2, 1 square root of 3, 1, 1, that will be. Now, cosine 45 is square root 3 over 2, and sine it's 1/2. So common denominator is 2 times square root of 3 is square root of 6, and square root of 2 times 1. Now, continuing question number 3, or example number 3, we have the formula which says tan theta. We said the numerator will keep the same sign. So if this is minus, that will be minus. Then here we will have minus tan beta times tan beta. So applying this rule for tan degrees, it will be equal to time 135 minus tan 60 degrees over 135 times tan 60. Now we have to be careful. 135 in the second quadrant, this is 135, 5, which is basically 180 minus 135. Now, STC will say tan is equal to negative of tan 45. So using this idea, tan 45 minus tan 60, tan, it will be minus tan 45 instead of tan 30 times tan 60. Again, for the table, this is 30, that is 3. And for 45, we know tan is 1 because this is 1 and 1, that's square root of 2. So we will have minus 1 minus tan 60. Opposite of 60 is root 3 over adjacent, which is 1. If we want to simplify this one more by multiplying by the conjugate, especially if it is a multiple choice, he might 1 plus square root of 3 and 1 plus square root of 3, conjugate, of course, of the denominator. So we will get in the denominator, the square of the first is 1 minus square of the second, which is 3. For the numerator, we will expand it. Minus 1 times 1, it's minus 1. Minus 1 times root of 3 is minus square root of minus root of 3. And minus root of 3 times root of 3 will be minus 3. So at the end of the day, 3 is minus 4, minus, and then we have 1 minus 3, it's minus 2, and that can be simplified, minus 4 over minus 2, which is plus 2, and minus 2 over minus 2 will be now. Example number 4, and that will say tan is equal to, numerator plus tan beta. So 120, that will be equal to tan 120, 145. Similarly, we go to, will be 180. So there it's the sum of 2 tan 120 minus tan 120 will tan the triangle. If this is 30 root of 3, tan 60 we have it's equal to opposite divided by 1, which is minus plus 1, 1 plus square root of 3. Similarly, if I want to simplify it more, I'll multiply by conjugate of the denominator, 1 minus root of 3. Of course, when we multiply by the same quantity. Again, it will be square of the first, which is 1, minus square of the second, which is 3. Expanding the numerator, minus root of 3 times 3 plus root of 3. This root of 3 will be minus root of 3. So that will be equal. So we said minus root of 3 times 1 is minus root of 3, and minus root of 3 times minus root of 3 will be plus 3. Okay, so I have minus root of 3 plus minus root of 3 minus 2 root of 3 and minus 2, which ends up would be square root of 3 plus 4 divided by minus 2 will be minus 2. Okay, so that is equal to square root of 3 minus 2. Now, next question, which we are using only radian, minus cosine will go to opposite sign, so this will be both cosine. Then if this is minus, that will be plus, and both sign. And of course, we need to use square root of 3. So if I have cosine pi over 4 minus pi over 3, applying the identity both cosine, then both sine. So if this is minus, that will be plus, and that will be both sine here. Therefore, this is equal to cosine is square root 2 over 2, because that's 45. Cosine pi over 3, it's 1/2. Plus sine pi over 4 square root of 2 over 2. Sine pi over 3, it's square root 3 over 2. Sine, it's opposite over hypotenuse. So common denominator is 4. So it will be square root of 2 plus square root of 6. Similar idea here we have plus beta will be both cosine. And if this is plus, that will be minus both sine. So applying this rule, cosine 3 by 6 will be both cosine and then minus. reference angle theorem, where because we know 3 pi, which is actually pi. This is the 3 pi angle will be just simply, therefore, STC will say cosine 3 pi over 4 times cosine pi over 6. And here, sine 3 pi over 4 will be the same as sine pi over 4. So that will be no change here. Okay, so STC over 4 will equal to negative cosine pi over 4. But the sign will stay the same. Sine 3 pi over 4 will still be plus sine pi over 4. Therefore, that will be minus root 2 over 2. Cosine pi over 6, remember the triangle. This is pi over 6. This is 2, 1 square root of 3. Of course, that's pi over 3. So cosine pi over 6 is root 3 over 2. And of course, here's sine pi over 6. Now, sine pi over 4, it's square root of 2 over 2. Sine pi over 6 is 1/2. So basically, common 6 minus root 2, because minus root 2 times root 3, it's minus root 6. Here we have tan, and we know tan alpha, that will be plus tan beta. Tan alpha times tan 4 tan pi over 6 plus tan pi over 3, 1 minus tan pi over 6 pi over 3. It will be tan. If this is a plus, that has to be, and the first angle is pi over 6 over 3. Now, that will mean will be 6. So if we have here 6, there's no change. But to make 3 6, we multiply it by 2 pi over 6. So that will be 3 pi over 6, which is pi over 2. We need the unit circle. So we have minus 1, 0. Now, of course, we know the x coordinate for pi over 2 will be, but sine pi over 2 is 1. Sine, sorry, if it is tan, will be sine over cosine, which means 1 over defined. Now, next question. It says write as a single trigonometric. Single trigonometric means one trigonometric. So if I have sine x divided by 3 times cosine 2x divided by 3 plus cosine x over 3 times sine 2x over 3. Of course, since it's alternating sine, cosine, cosine, sine, this must be equal to sine, first of all. And we said sine preserve the sign. So if this is a plus, that must be also 3. The second angle is sine 3x over 3, which is basically sine x. So that's the single trigonometric function requested. Now, x minus tan 3 minus tan 2x times tan 3x. So the rule for tan, it says if this is minus, that will be also minus. And it will be tan, the first angle, which is 2x, but that will equal to tan what? Negative x. But we know it is odd. It means that will be negative of tan x. Now, I have here sine. I have sine 12 degrees. Sine. There is a mistake here. It should be sine 42 cosine 12 cosine. Okay. So 2 times. Need to change back the color. We know sine preserve the sign. Sine preserve the sign means if this is minus, also that will be minus. And that is first angle again, which is 42. Second angle, it's 12. So that's 30, and we know sine 30 from the table of the triangle, it's 1/2. Now, We'll take the next example. Okay, 5 by over 4 by over 12 over 4. It's the same thing here, guys. It is sine, cosine, and sine preserve the sine, which is angle. As we said just in a few seconds, is a multiple of 4. Sorry, 4 is a multiple of 12. So if we multiply by 3 up and down, we will get here. This is 5 by over 12 minus multiply by 3 here, by 3 there. So it will be 3 by sine of 5 by minus 3 by, it's 2 by over. Simply it is sine of by over 6. So it is sine by over 6 triangle, our famous triangle. It's by over 3 over 6. It's 1/2. The last question, I guess. No, not the last. Question number 12. Use cofunctions identities. Remember cofunctions identities, its degrees or y over 2 minus alpha will change to cosines. Minus alpha sine 55 degrees. If I change it to cosine, that's all. So it will be cosine of 10 minus 5, it's 5. Minus 5 is 3. That is basically sine the angle is cosine the complement, because 55 and 35 are complement of each other. 80 degrees minus is sine of 10. As I said, cosine the angle 80 is equal to sine the complement of 80, which is 10. This will end up our section for section 6.2, which is sum, difference, and cofunctions identities. Let's stop the recording.